Okay, so a couple of mechanic things. There will be a weekly review dinner. It will be normally Tuesday nights. This week it's going to be a little bit tough because I'm going to Boston for some continuing ed lectures, and my son Cam is sick. I will find out exactly how sick in a little bit. So I will only be in my office from 2:30 to about maybe 3 o'clock today. If you want to meet or chat, just send me an email and we'll find a time to connect. There will be weekly lunches for people who want to talk about applications of mathematics. Those will start next week. Just send me an email if you want to talk about stuff like that. I'll be sending a detailed email with more mechanics about homeworks and stuff like that, and about the different things for the class. The first exam is going to be on Friday, February 28th in all probability. It will be cumulative on material, not just Chapter 11, but Calc 1, Calc 2, with basically just derivatives, integrals of simple functions, maybe integration by parts, nothing like partial fractions, volumes of washes, stuff like this. The exam is mostly diagnostic. I want to get a sense of where you stand. Yes?
When is it, the 28th?
Probably Friday the 28th. Okay. Any other general questions before we begin? Okay, so today's lecture is one of the more painful lectures of the semester. So I apologize in advance. And so there's two possibilities. I can put on a cheerleader outfit and try to go rah, rah, rah and excite everybody about this, or we can go warp speed and get through it as fast as possible. I prefer the warp speed approach, and let's just get through the material as quickly as we can. Today is mostly about notation. You can define anything you want. The question is whether or not you can get people to accept your notations, and whether or not those notations will be useful. Okay, anybody know what a smoot is? A smoot is a unit of distance. Smoot was an undergraduate at MIT, and his fraternity picked him up and moved him down one of the bridges over the Charles River in Boston. And they put down markers every time they marked off an entire smoot lane. The police didn't really like this, they painted over it. The fraternity didn't like this, so they picked him up again and they did this again. And they kept going back and forth. And eventually people found it endearing, and now when there are accidents on this bridge, they tell you how many smoots, across the bridge the accident happened at. In a nice twist of fate, smoot became the head of the Bureau of Weights and Standards. Okay? For the most part, smoot is not a good unit of measurement. It's not a good notation for distance. It's not very reproducible. What I want to do today is talk about good notations. Okay, so we're going to start off with a lot of definitions. So, n is going to be the natural numbers, and that's going to be numbers like 0, 1, 2, 3, ... So some people decide whether or not they want to include 0 or not in the natural numbers, and they talk about the whole numbers. I don't really want to get into that. After the natural numbers come the integers. And we denote these by these, strange, like blackboard font n's and z's. And this is just to distinguish it from the regular n and z, to let us know that this is something special. We're using this to denote the integers. And this is going to be ... -2, -1, 0, 1, 2, ... Now, the question is, why are we denoting it by z? Z is from the German for Zahl. So that's German for number. And so it took a while before we start getting terms defined by the English, and not just terms defined by the French and the Germans. After the natural numbers and the integers, the next thing that we get are the rationals. And these are all things in the form p over q. P and q are integers, and q does not equal 0. And we call this q for quotients. Next is r, and this is the real numbers. And this is all numbers, x, think of it as, infinite decimals. We're not going to do too much with them, but you should be aware of the complex numbers. So C is the complex numbers. And these are all things of the form z equals x plus iy. I is the square root of -1. Okay. One quick remark. I should have said this at the beginning of class. I promised I would call on people randomly or semi-randomly to decide, who's going to speak about today. So I will randomly choose myself. Right? So if you'd been called on today to summarize what was today's lecture about, something along the following lines would have sufficed. Today we're going to talk about properties of vectors, we're going to talk about their definitions, we're going to talk about their basic properties, we'll talk about lengths, and maybe talk a little bit about angles if time permits. Something along those lines is all I'm expecting of you in terms of being prepared and being able to quickly summarize for the class. If you do not know what we're going to talk about, if you're processing everything for the first time, it's going to be extremely difficult. Right? So for the most part, this is good notation. Notation has a tendency to stick, and it becomes very hard to change. One of my favorite examples is, who can tell me what QWERTY is? Yes?
The order, how our keyboard is organized?
So why do we organize our keywords in a QWERTY way?
Because if it were alphabetical, people would type too fast and jam their typewriters.
Yes. Now, of course, people don't really type on typewriters anymore. But in the old days, people would type on typewriters, and if you typed too fast, they would lock together and things would break. So the typewriter, the keyboard, is deliberately designed to slow us down. It is ridiculous in the 21st century that we still have QWERTY keyboards. Okay? It's not my fault, it's my colleagues' fault who are not willing to learn Dvorak or the other keyboards. But we now force our children to learn this as well. Okay? It's very hard to change things. I'm not even going to ask who has sent an email in this class. I'm going to assume everybody has sent an email at some point in their life, and everybody has CC'd somebody. What does CC mean? Yes?
Carbon copy.
Carbon copy. Okay, again, 21st century, and we're talking about carbon copy on an electronic message. Yeah, maybe you still see carbon copies at tourist traps where they don't have the credit card machines and they make a copy of your credit card. Some people have changed CC to now mean courtesy copy rather than carbon copy because it's so ridiculous. Notation sticks. It's very hard to change. Okay? So again, this is pretty good notation here. What I want to do now is I want to talk a little bit about vectors. And I want to talk about some notation for vectors. So before I can do vectors, I need a little bit more. So we say f from A to B means f takes elements of A as input and outputs elements of B. Okay? So when I'm describing functions, I need to know where do they live. Where's the input coming from? Where's the output coming from? So whenever you do a new concept in math, you should always ask, does this generalize something I know? Well, this is Calc 3. If you had to guess, what class is this generalizing? What class or classes would you guess? What do you think Calc 3 generalizes? What classes? Yes?
Calc 1 and 2.
Calc 1 and Calc 2, right? Whenever I give you a concept in Calc 3, try to think of a similar concept in Calc 1 or Calc 2. Well, in Calc 1, how many inputs do you have? Your functions of how many variables? One variable, right? So in Calc 3, we're going to deal with functions of several variables. And so we need ways to denote these sets. So in one variable, we talk about functions on the real line. Here, Sn means n copies of S. So for example, Rn is going to be the set of points x1, x2, ... xn, where each xi is a real number. So I'm jumping to the punchline right now. I'm going to go back a little bit and try to explain why this is good notation. This is not QWERTY notation. This is notation that deserves to be immortalized and kept. Okay? If I give you R2, this means I want pairs of real numbers. How would you denote a pair of real numbers? What letters would you use? So one real variable, you just use x. For two real variables, you would use x and y. So it would be xy, xy are real numbers. If we did R3, how would we do it? XYZ. Now fortunately, for a lot of applications, 3 dimensions is enough. If you want to describe my motion in this classroom as I'm writing, probably 2 dimensions is even enough. I'm not really jumping up for joy too much. That's other colleagues of mine. If you want to describe the orbits of the planets about the sun, 3 dimensions is better. But for any physical object in the world, you can describe its trajectory with just 3 real numbers. But maybe you also want to record how fast it's moving. And as soon as you want to do that, you start to need more than just 3 variables. Or maybe you're studying some very complicated economic system, and you have lots of different parameters as well. So you have a desire to look at things that have more than just 2 or 3 inputs. Now in terms of what is the difference, well, I can just keep adding more letters. That's not so bad. In terms of visualizing things, it's very hard. I can visualize a function of 2 variables. What's a function of 2 variables? Think of it as a weather map or a temperature map. I give you a nice, the United States of America, I put it on a flat surface, and for each point, I go up how high the temperature is. So, today we're not going to have to travel too high up, but, eventually, we will climb up a little bit, we will see good days again. Okay?